So Rich, could you turn off the front? So you can use your formula sheet or you can add it to your study sheet. So this is supposed to be filled in. Go look at Monday, October 31st, right? And now we will go to the back to this question right here. So I did this on the video. I did this, and I'm gonna just briefly go over this one right here. I gave you the answers on the video, but here it is, just worked out. Okay, and we're not waiting here. So let's do this one here. Follow me. Have your calculators ready. So what are we doing? We're determining the perimeter of this polygon here. What is the perimeter? The distance around, right? Think of Winnipeg's perimeter, right? That'd be around the city, right? Same here. So basically what we want to do is figure out this stretch right here. And if we do, we can just multiply that answer by the number of sides. Right? That's what we're going to do. So the first step here, when you have one of these up here, this angle right here is what we call a central angle.
Good afternoon, ladies and gentlemen. Just so you know,
there we go. What is this called here? Central angle. Follow along, guys. Central angle, how do we find it? What's the formula for central angle? 360 divided by n. N stands for number of sides, right? So this is how I want you to count. You make a check mark because you start here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. This is an 11-sided polygon, right? And we're working with regular polygons. So central angle is 360 divided by 11. Okay. And what do we get there? Okay. So we'll just do 2 decimals. Okay. 7.3, right? It rounds to 7.3. Underline that. That's very important because now we just found, right? This angle right here is this sliver in there. That's what you just found. And how is that important? Because it's a regular polygon, we know that this side is the same as this side. So you can actually, I'm going to use a different color. Right? This is 24.5 feet. Right? So you have side, angle, side now. Right? You can find Z, cosine law. That's right. Hold it. Interior angle is 180. Okay. That the sum of all 3 is 180. Okay. Zach is going sine law here, right? That's what you want to do? Yeah. Well, okay. What Zach is what you're saying is subtract this from 180. Divided by 2, and then you'll have both of these. Yes, and then you could go sine law. You can do that. I feel like it's about the same amount of work or more. So it's all connected. It's still the same. Pay attention, guys. Okay. Okay. You know what, guys? Everybody else, then I'm starting to get upset. Okay. So we have a side angle side, right? So we're gonna write this down just for our notes. Right, this is 32.73 side angle side. This is Z. Okay, so to find Z, obviously you square it, and then it's 24.5 squared plus 24.5 squared minus, you know the drill by now. If you watch the video, you know what's happening. You've tried this already, right? And then it's cosine of 3273. Okay, so Z is square root of all of that. And I just have to run it through real quick here. That's 190.606, and that keeps going. We take the square root of the entire thing, and we get 13.81. And we have feet. Actually, I probably in the notes didn't round it just yet, right? I probably would have kept it at 4 decimals. You could tell that that was an older video, right? So the perimeter is, in this case, how many sides do I have? 11 sides, right? Times 13.8060. And that's the answer that I write down. So the perimeter is 151.87 feet. Okay, so it starts with, you know, I can tell you this. With polygons, you know where it really starts every time is finding the number of sides it has. That's where it all starts. If you know the number of sides, there's a lot of things that you can figure out about that polygon, right? So there it is. Everything else is in the video that I posted yesterday, so go and get it there. If you don't, you're going to feel it on the test for sure. Okay. All right. Question 7. We'll do some backwards, right? Given the angles, find out how many sides it has. So put a big heading here. We're going to go backwards. Okay. Make sure you have that written down above 7 so you know that that's what we're doing now. I will even highlight that. Backwards. Start with a formula. Right? Then find n, right? You want to find the number of sides. Start with a formula, then find n. What formula? In this particular case, it says a regular polygon has exterior angle, right? Exterior angle. Somebody start with the formula, then find n. So the formula for exterior angle, this word right here tells you that you have to use the formula. Exterior angle is 360 degrees over n. Okay. And then substitute in. I will use a red pen for that part. Right, the 40 goes in for exterior angle. Right? And this is 360 over n. Don't guess with these ones. Like, I don't want you to just say, I think n is about 10, right, or 9. Like, I want you to show those steps, right? So substitute in, right? That one. In this case, you will be given the actual value, right, that you used to calculate. Now it's given. And what do I do here? I go a little trick, right? This is the trick of the trade. I put a little 1 under 40 because it doesn't affect it, right? And then you just go 360 times 1 divided by 40. Okay? 360 times 1, which is just 360, right? Divided by 40. And you get that n is equal to 9 sides, right? That is the one of the easiest examples here, but it can be done, right? So start with the formula, substitute in, and then proceed to solving for the number of sides. Okay, so do we have that? Yeah, okay. Can you try one right here? What if the exterior angle is 24 degrees? What would the number of sides be? Apply what you just learned here. I used a lot of space here. You don't need that much space. What if I said, hey, the exterior angle is 24 degrees. How many sides would it have? No guessing. Show the steps. Okay. The province wants you 360 divided by 24. It's 15 sides. Okay. And so there you have it. So that's a 15-sided polygon. You don't really need to know. There might be, like, I expect you to know, like, a hexagon has 6 sides. I expect you to know that a decagon has 10 sides. But most of the time, I will give you what the number of sides are. Okay, let's keep going. Back side of that, so that's already page 204. Okay, on page 204. What are the sizes of the interior angles of a regular hexagon? That one I expect you to know how to do. Can you do it if I give you an AC right now? What are the sizes of the interior angles of a regular hexagon? Remember, polygon, how many sides? 6 sides, right? Interior angle. So the interior angle calls for what formula? N minus 2 times 180 divided by N. Okay? So the interior angle would be 6 minus 2 times 180 divided by 6. Okay? Let's clean it up a little bit more. This is really 4 times 180 divided by 6. You can get an easy mark, but if I just ask you, hey, calculate the interior angle for this polygon. 4 times 180 divided by 6. I will refresh it. Only works for what kind of polygon? There's irregular and there's regular. This only works for regular polygons. Okay, why is that? Because it's assuming that every angle is the same, right? Like if that's what you're assuming here, that's why you're dividing by n, right? Okay, now a harder one. Okay, and then you'll try one right after this. A particular regular polygon has an interior angle, watch this, of 135 degrees. Determine the number of sides. Okay, so can you use the formula for interior angles in this case? You technically could. It's going to be very complicated, very difficult. A lot more difficult. This is what I'm going to do, the trick here. If the interior, if I is equal to 135, write that down, comma, then what's the exterior angle? There are 2 ways to figure out the exterior angle of a polygon. If you watch the video, you know exactly what I'm talking about. If you zoom into any particular corner, or what does the interior exterior always add up to? Maybe that will ring a bell. They always add up to 180, because if you zoom in, let's go back in time a little bit. Did you say 360? Hey, you at least gave it a go, right? Zoom into any corner here. Let's zoom into this one right here. This is an interior angle right there. And how do you make an exterior angle? Do you remember? You travel along the side, and instead of turning, you keep going straight. Right? You keep going straight. So this is the exterior angle. Every corner has an interior and an exterior angle associated with it. So what do these two add up? I plus E is always 180. Yeah. So that's what I'm going to use, that trick. And then you're like, but Mr. Dixon, isn't E just 360 divided by N? Yes, as well. Yes, that's true. Okay. So let's keep going here. If I is equal to 135, then E is 180 minus 135. You can't use the formula because you don't know how many sides there are. You have to rely on this. And what is the answer to this one? Mental math. It's a little too high. 45, right? Because you need 45 to get to 180, right? And so why am I doing this, Mr. Erickson? Why am I doing this? Well, because I just showed you, right? Once you have the exterior angle, are you able to find the number of sides? Yeah. So now use, right? E is equal to 360 over N. All right. And then we now know that it's 45 degrees. So we're going to go 360 over N. We're going to put the 1 underneath. And it's 360 times 1 divided by 45. So there's a little trick that you need to do. And then it's back to what we just did. What's 360 divided by 45? That's 8. What do we call an 8-sided polygon? Yeah. It's a stop sign, yeah. You just don't call it that, but yeah. Let's try it right away here. I'm going to give you a different one. Let me just give this a try here. What if angle I, the interior angle, is 168 degrees? How many sides does it have? Go for it. That can give you 2 to 3 marks, just like that on a test. If you know what to do, you need to know what needs to be done, right? So earlier I gave you this interior angle. How did you get to N? Try that right now. Give it a try. Zero risk. If you get it wrong, it's just, oops, I got it wrong. Sorry. 360 times 1, right? 360 divided by 12. And what's 360 divided by 12? 30. Can I just say something? If you ever get a decimal, you made a mistake, right? It can't be done. Like, it has to be a whole number. Okay, let's keep going. What does it mean for a polygon? What does it mean for a polygon to be regular? All sides are congruent. That's the symbol for congruent, or are the same, right? All angles are. So if you're going to study for this test, there's going to be a lot of multiple. This one is going to have about 10 to 12 multiple choice questions. Just properties, properties, properties. Can you sketch and label, right? All those things. So a lot of it is going to be quick, just like that, right? So you can score easy marks. I'm just going to say that, right? Watch this. A hexagon has the following interior angles. Hexagon, 6 sides, right? Determine the measure of the 6th angle. Okay. How are we going to do this? First of all, you need to know the sum of a 6-sided polygon is of a 6-sided? That's a 4-sided. But let me back up here. This is the formula. Actually, you don't have the n on yours, do you? Just like that. The sum of interior angles is n minus 2 times 180. You get it every time. right? Figure out the sum. So if it's a 6-sided, then it would be 6 minus 2 times 180, which is 4 times 180. And what is that? 720 degrees, right? I'll make a note here. All interior angles add up to 720 degrees, right? That's what you just found here. So that's step number 1. Okay. Sixth angle is going to be, how would we find the sixth angle? We take the 720 degrees and we subtract what we know, right? We know the 125, the 119, the 117. There are 2 angles that are 124. So you either go 124 twice or you just go times 2, right? So I'm going to actually do this here with you. Grab a calculator, right? 720 minus 125 minus 119 minus 117 minus 2 times 114. Oops. And you're left with 131 degrees. That is your sixth angle right there. Question, is this a regular polygon? So not regular, right? They're all different. Okay. Not a regular polygon, right? And this is the answer. All angles, not all, but angles are not congruent, right? Angles are not all congruent, right? And we can therefore make already an assumption that the sides will also not be congruent. So that's your sixth angle right there. Okay. Polygons, polygons, polygons. Okay. So follow me here. I would like you to, these questions here, once we get to 11, they're okay. Looking at the time, so go to page 211. And let's read it together because I want you to get started today. Okay, you need to try polygons because it's a significant amount on the test. So Prince Edward Island is known for its many lighthouses. Sea Cow Head Lighthouse was built in 1864. The base is in the shape of a regular octagon. There it is. Okay. Each side of the regular octagon is 3.4 meters long. What is the area of the floor? Have we done areas of polygons? But you can cut them up into triangles, can't you? So you go the same principle as we did the perimeter. But we're going to change that. We're going to change that because I just need you to be able to do the perimeter. So what is the perimeter? Can you put down perimeter above it? What is the perimeter of the floor? And I'm going to ask you to erase the hint. Okay, just get rid of that hint. Don't worry about it. Just go figure, like, just look at the examples I did previously. We're going to do this. Go on this diagram here. We're going to call this X. Okay? And we will go A, calculate X, right? And B, determine the perimeter. So we're going to slice it up into A and B. Calculate x and then determine the perimeter. And for 4, go with me to 4 here, to the question right underneath. I want you to calculate, right, where it says A is right there, B, and we'll just put them close together and then you have room to work around it, right? So C, calculate the exterior angle. There are 2 methods here. I want you to show them both. D, calculate the central angle. E, calculate the number of diagonals. So this is for today. I'm going to leave it at that. I want you to give this a try. I will post the key to this. Okay, I will post the key to this page.